Hello students, this is grade 10 physics class, chapter 12, electricity. In previous video class we have seen what is resistance and SI unit of resistance, and then what is 1 ohm. Am I right? Yes. In this session we are going to start our next topic. What is that? Our next topic. Yes. In order to start our next topic, we must recall what are the things we have seen in previous video class. Is that clear, students? Yes. Actually, in previous video class we have seen resistance. Am I right? Yes. Resistance of a conductor. Yes. Actually, what is resistance, sir? You tell me, what is resistance? The title itself reveals the answer. Resist. Something which resists to flow of electrons, that is called resistance. That is called resistance. Yes. For example, take a copper wire or any other conductor, connect the two ends of the conductors along with the two terminals of the battery. Yes. So when the potential difference is applied by this battery or any other power source, what will happen? Electrons will start flow from one part of the conductor to another part of the conductor. Yes, obviously we know very well. Yes. When the electrons starts moving from one part of the conductor to another part of the conductor, it will collide with, note this point, it will collide, which means it will fall with other atoms, which means protons, other atom protons and neutrons, and then other atom electrons also, isn't it? Yes. So when the electrons starts moving from one part of the conductor to another part of the conductor, it will collide with other atoms and other electrons continuously. So this collision is called resistance. This collision is called resistance. So due to this collision, there is some obstruction, which means opposition to flow of electrons. That is called resistance. That is called, what is that? Resistance. Yes, due to this collision, the current value also decreases. Am I right? Yes, the current value also decreases, because what is current? The flow of electric charge is current, which means the flow of electrons is called current. Due to this collision, the electrons moving a speed, which means electron movement is opposed here, due to which the current value also decreased. Is it clear, students? Yes. That is the reason why the resistance, which is inversely proportional to, this current is inversely proportional to, what is that? Resistance. If the resistance value decreases, then current value gets if the resistance value increases, current value decreases. If the resistance value decreases, current value increases. So that is the reason why current is inversely proportional to resistance. If the collision is more, then the current value will be less. If the collision is less, then current value will be more. That's all. Very easy. Okay. Yes. So finally, what is resistance, sir? The collisions between the electrons and the other atoms, that is called, what is that? Resistance. That is called resistance. Yes, these collisions, the opposition to the flow of electrons is called, what is that? That is resistance. Is it clear? Yes, very easy one. Yes. Next one, what is SI unit of resistance, sir? What is SI unit of resistance? The SI unit of resistance is ohm. What is that? That is ohm. O-H-M. Ohm. Is it clear? Yes. Then the symbol of the ohm is like this. It will be like this. This is ohm symbol. Okay. Actually, it's a Greek letter. It's a Greek letter. Its name is omega. Omega. Okay. Yes. So the SI unit of resistance is ohm. Then the symbol is omega, like this. Is it clear? Yes. Next one. So already we know resistance, which is equal to, what is that? Potential difference divided by current. Okay, which means R, which is equal to V by I. V by I. Yes. This resistance, which is equal to potential difference divided by current. Potential difference divided by current. Is it clear? Yes. So already we know the resistance SI unit is ohm, then the potential difference SI unit is volt, then obviously the current SI unit is ampere. Yes. So 1 ohm which is equal to 1 volt divided by 1, what is that? 1 ampere. Yes. So 1 ohm which is equal to 1 volt divided by 1 ampere, because resistance SI unit is ohm and potential difference SI unit is volt, then current SI unit is ampere. So 1 ohm, note this point, 1 ohm which is equal to, what is that? 1 volt divided by 1 ampere, which means, what is that, sir? What is it meaning, sir? When 1 volt potential difference is applied across the two ends of a conductor, the 1 ampere current flowing through it, then the resistance of a conductor is said to be 1 ohm. Resistance of a conductor is said to be 1 ohm. Suppose the 2 volt potential difference is applied across the two ends of a conductor. Yes. Then 2 ampere current flows through it. How much? 2 ampere current flows through it. What about the resistance, sir? Yes, the resistance will be 2 ohm. That's all. 2 ohm. Yes. So when 1 volt potential difference is applied across the two ends of a conductor, two terminals of a conductor, the 1 ampere current flowing through it, then the resistance value of the conductor is 1 ohm. Actually, resistance, what is resistance? The collision is called resistance. This collision is depend on, what is that? The potential difference. Am I right? Collision depend on potential. The potential difference is more, then the collision will be more. Is it clear? Yes. That is depend on the size of the length of the conductor and the area of cross section of the conductor and temperature and so many things we will see one by one. Okay. Yes, that's all. So that's all about the 1 ohm. Is it clear, students? Yes. So I think till now we have seen up to this. Yes. Till now we have seen up to this only. Yes. In this session we are going to start the new topic, that is experiment to verify Ohm's law. What is that? Experiment to verify Ohm's law. Okay, so till now we have seen theoretically what is Ohm's law. Theoretically what is Ohm's law? So theoretically what is Ohm's law, sir? At constant temperature, the current flowing through a conductor is directly proportional to potential difference across the two terminals of a conductor. Am I right? Yes. Practically, which means experimentally, how can we verify Ohm's law, sir? Verify Ohm's law. So already we know, according Ohm's law, I, which is directly proportional to V, which means V is directly proportional to I. If the potential difference increases, current value increases. If the potential difference decreases, current value gets decreases. Is it clear? Yes. Because what causes current? The potential difference causes current, due to which I is directly proportional to V, or otherwise we can say V is directly proportional to I. Is it clear? Yes. Till now we have seen theoretically what is Ohm's law. But in this session we are going to start with experimentally how to prove Ohm's law. Is it clear? Yes. So next topic is experiment to verify Ohm's law. Experiment to verify Ohm's law. Is it clear? Yes. Experiment to verify Ohm's law. Actually, we have a experiment, okay, which means practical. After school reopens, we will do in laboratory, physics laboratory. Is it clear? Yes. This experiment, this practical, we have that. Okay. Yes. You need to write in record note also. Okay. Yes. So next one, the experiment to verify Ohm's law. How to prove Ohm's law experimentally? Is it clear? Yes. To prove the Ohm's law experimentally, we need circuit diagram. That is Ohm's law circuit diagram. Okay, yes. I'll draw this Ohm's law circuit diagram. Please note this in your classwork. Note, it's very, very important circuit diagram. It will be helpful for even 12th standard also. Okay, yes. So draw this diagram neatly in your classwork note. What is this? This is battery. Am I right? Yes. Battery which is used to produce potential difference. Yes. Next, Ammeter is here, ammeter is here, then the key is here, and this is resistance, sorry, that is a rheostat. Okay, I'll complete the diagram, listen here. Yes, this is unknown resistance. Actually, this is conductor. What is it? This is conductor. It's a conductor. Okay, yes. Positive terminal of the battery, negative terminal of the battery. This is positive terminal of the ammeter, negative terminal of the ammeter. Yes, look at here, this is conductor. Okay, maybe it's a nichrome wire. I am going to take nichrome wire. Nichrome is one of the conductor. Even though that is alloy, that is one of the conductor. Yes, nichrome wire. Yes. Across the two terminals of the conductor, I am going to put voltmeter parallel to this conductor. Parallel to this conductor. Yes, this is one end, this is another one end. Okay, students, yes. What is this? This is battery, and this is ammeter, and this is key, which means switch. This is a rheostat. This is rheostat. Okay, yes, and this is voltmeter, and this is conductor, the unknown resistance. We are going to find out the resistance of this conductor. Is it clear? Yes, this is conductor. Nichrome wire. Nichrome is one of the good conductor of electricity. Even though that is alloy, it is one of the good conductor of electricity. Is it clear? Yes. So this is a Ohm's law. This Ohm's law circuit diagram. Ohm's law circuit diagram. Is it clear? Yes. So please note down this circuit diagram so neatly in your classwork note. This is very, very important circuit. This circuit will be helpful for even a 12th standard also. Okay? Yes. Listen here. So now we are going to verify practically. Okay, practically Ohm's law. Okay, so already we know what is Ohm's law. So V, which is equal to IR. Potential difference is directly proportional to I. The potential difference which is directly proportional to I. Okay, which means when the potential difference increases, the current gets increased. The potential difference decrease, current gets decrease. Isn't it? Yes, because what causes current? The potential difference causes current, due to which the potential difference is directly proportional to current. Is it clear? Yes. So in order to remove this directly proportional, we need to put the proportionality constant. Am I right? Yes. So which is V equal to IR. Here what is R? R, this is constant. R, which means constant. What is that constant, sir? That constant is resistance. That constant is resistance. So obviously the Ohm's law will be V, which is equal to IR. Okay, which means what is that? R is a constant. Whose constant? This conductor constant. Okay, this conductor, the resistance value will be constant. Is it clear? So whatever the potential difference and current flowing through it, here this conductor resistance will be constant. That is the reason why here R is constant. Is it clear? Yes. Look at here, this is a Ohm's law circuit diagram. This is battery, the positive terminal of the battery and negative terminal of the battery. Then this is here, the ammeter. This ammeter is connected with series. Okay, series to the power source, which means potential difference. Is it clear? Yes. Why here the ammeter is connected series to this potential difference? Because the ammeter has low resistance. Is it clear? Ammeter has low resistance. That is the reason why it is connected a series to this potential difference. Is it clear? Yes. The next one, this is key, which means generally this is which is used to power on and power off to overall circuit. Next one, rheostat. Actually, this is a new device for you. Am I right? Yes. Rheostat is a device which is used to change the current value. Note this point. Change the current value without changing this potential difference. Okay, note this point. Rheostat is a device which is used to change the current value without change this potential difference across the two terminals of this conductor. Is it clear? Yes. So next one, this positive terminal of the battery is connected with one end of the conductor. Okay, here for example I have taken a nichrome wire because nichrome is one of the good conductor of electricity. Even though that is alloy, that is a good conductor of electricity, isn't it? Yes. Next one, then next end of this nichrome wires connected with rheostat. What is that? Rheostat. There will be upper slot to connect the wire. Okay, yes. Here second end of this conductor is connected with the upper slot of the rheostat. Yes. Next one, this negative terminal of the battery is connected with the positive terminal of the ammeter. Then negative terminal of the ammeter is connected with one end of the switch. Okay, it may be whatever it is. Okay, because here the key has a two end, the two terminals. We can connect whatever it is, whatever the term. Okay, yes. Next one, the another one end of this key is connected with another one end of the rheostat. Is it clear? Yes. Look at here. Here, the voltmeter. What is this device? The voltmeter. So voltmeter which is used to measure the potential difference, how much amount of voltage which is passing through this circuit. Is it clear? Yes. So voltmeter is connected parallel to this conductor. Am I right? Yes. This is conductor. This voltmeter is connected parallel to this conductor. Why, sir? Next question rising here. Why here voltmeter is connected parallel to this conductor? Why? Because here the voltmeter has high resistance. What is that? Voltmeter has high resistance. That is the reason why it is always connected parallel to this conductor, parallel to a potential difference to be calculated. Okay, yes, because it has high resistance. Suppose if the voltmeter is connected series to this potential difference, this voltmeter will affect the current flowing through the circuit because it has high resistance. Is it clear? Yes. That is the reason why the voltmeter is always connected parallel to the conductors where the potential difference to be calculated. Isn't it? Yes. So this is Ohm's law circuit diagram. Okay. Yes. So please draw neatly in your classwork note. Is it clear? Yes. So this experiment we will do after school reopens. Okay. Yes. Here, what is the concept, sir? Here, what is the concept, sir? Okay. So look at here. This battery which is used to produce potential difference. Yes, am I right? Yes. The battery which is used to produce potential difference. Next, this ammeter which is used to measure how much amount current flowing through this circuit. Is it clear? How much amount of current flowing through this circuit? Is it clear? Yes. Next, this key which is used to allow the current to pass through the circuit. Okay, which means switch on and switch off. Isn't it? Yes. Next, this conductor. Now we are going to find out this resistance of this conductor. What is that conductor? Nichrome wire. Now we are going to find out the resistance of this conductor. Is it clear? Yes. Next, the voltmeter which is used to measure the potential difference. Generally we say voltage. Yes. Potential difference, how much amount of potential difference, which means voltage which is passing through this circuit. Is it clear? Yes. Next, rheostat. Already I said that. What is rheostat? Rheostat is a device which is used to change the current value without changing this potential difference value. Is it clear? Yes, that's all. Look at here. So next, I'm going to make a tabular column. This is Ohm's law tabular column. First one is the serial number, and second one, how much amount of current flowing through this conductor. Which conductor? So nichrome wire. Yes, this is unknown resistance. Next one, potential difference, PD, which means what is that? Potential difference. Yes, potential difference through the conductor. Potential difference through the conductor. And last one, that is resistance value. Resistance of conductor. So potential, the current flowing through the conductors in the measurement of what is that? This is I in ampere, because current SI unit is ampere. Then next one, the potential difference V in volt, because SI unit of potential difference is volt, okay, which means voltage. Next, the resistance of a conductor R, that is in ohm. Is it clear? Yes. Okay, listen here, this is Ohm's law, tabular column. Okay, yes. Next, what is the concept, sir, here? What is the concept? So already theoretically we know what is Ohm's law. At constant temperature, the current flowing through a conductor is directly proportional to potential difference across the two terminals of the conductors. Already we know very well. Is it clear? Yes. Experimentally, how can we prove that, sir? Experimentally, how can we prove that, sir? Is it? Look at here. This battery which is used to produce potential difference. Am I right? Battery is used to produce potential difference. Is it clear? Yes. In battery, a set, for example, 10 volt potential difference. Okay, here battery is a main power source. Battery is a main power source. In that battery, you set, for example, you set 10 volt potential difference. How much? 10 volt potential difference. Is it clear? Yes. In the circuit, how much amount of potential difference flowing through it? 10 volt. 10 volt. Is it clear? Yes. Look at here. Already we know what is rheostat. So rheostat is a device which is used to change the current value without changing this potential difference. Am I right? Without changing this potential difference. Is it clear? Yes. So with the help of this resistance, you continuously, okay, so you are going to continuously change the current value. Is it clear? Yes. Look at here. This is a rheostat. Yes. So without changing this potential difference, you change the current value. How much amount of current flowing through this circuit? Is it clear? Yes. Suppose, look at here. Serial number 1. Suppose 1 ampere current is flowing through this conductor. Okay, through in this circuit. How much amount of current flowing? 1 ampere current is flowing through the conductor. Yes. Here the potential difference value will be 2 volt. This is for an example. This is not for exactly we can predict that. This is for an example. Okay, I am writing here only for example. Is it clear? Yes. Next, again adjust this rheostat. Okay, you set the current value in ammeter, that is 2 ampere. How much? That is 2 ampere. The correspondingly the voltage value should increase. Am I right? Because that is Ohm's law. I, which is directly proportional to V. So if I increases, V also should increase correspondingly. Am I right? Yes. So when 1 ampere's current is allowed to this along with this conductor, the potential difference value is 2 volt. Yes. So when 2 ampere current is allowed, so along with this circuit, the potential difference value will be 4 volt. Okay, this is for an example. You don't get confusion. Okay, yes. The potential difference value is 4 volt. Is it clear? Yes. So when I increases, correspondingly V also increases. Is it clear? Yes. Again you change the current value into 3 ampere. Again you change the current value into 3 ampere. What about the potential difference? The correspondingly potential difference value should increase. So it may be 6 volt. It may be 6 volt. Is it clear? Yes. Again you change this current value, again the correspondingly potential difference will change. Actually it is increases, so its value will be 8 volt. Okay, yes. So finally we got 4 values. Look at here. So according to Ohm's law, whenever I increase the current flowing through the circuit, correspondingly voltage also increases. Voltage also increases. For 1 ampere current, how much potential difference? Potential difference is 2 volt. Yes. For 2 ampere current, the potential difference 4 volt. For 3 ampere, the potential difference 6 volt, and for 4 ampere, the potential difference is 8 volt. 8 volt. Is it clear? Yes. So what is meaning, sir, here? What is it meaning, sir? So already we know R is constant. Am I right? So R value is, what is that value? Constant value. Yes, look at here. Now we are going to find out the R value. So what is the R value formula? R, which is equal to V by I, which means resistance which is equal to potential difference divided by current. Am I right? Yes. So according to Ohm's law, V equal to IR. So R, which is equal to V by I. R, which is equal to V by I. Am I right? Yes. You substitute this potential difference value and current value, we can get the resistance value. Am I right or wrong? Yes. So here, substitute this all values. So R, which is equal to V value how much? V potential difference 2 divided by then current value 1. Yes. So 2 by 1, which is equal to, yes, 2. So resistance value how much? Resistance value 2 here. Yes. Look at here. For and the 1 ampere current flowing through this conductor, so the resistance value is 2 ohm. How much? 2 ohm. Is it clear? Yes. Next you calculate for second one. Yes. So R is equal to V by I, and V value which is equal to 4 divided by and I value 2. So 4 by 2 which is equal to, yes, that is also obviously 2. Yes. So what is this meaning, sir? What is this meaning? So when 2 ampere potential difference is applied across the 2 terminals of a conductor, the 2 ampere current flowing through it, then the resistance of a conductor is 2 ohm. Resistance of a conductor is 2 ohm. Is it clear? Yes. Next you substitute the third one. Yes, R which is equal to V by I. So V value is 6 and I value is 3. So which is equal to how much? 6 by 3. Yes, that is also 2. So what is the third one meaning, sir? Third one, look at here. So when 6 volt potential difference applied across these 2 terminals of the conductor, the current flowing through the conductor is 3 ohm, then the resistance of the conductor is how much? 2 ohm. Resistance of the conductor is 2 ohm. Is it clear? Yes. Again you calculate for final one. So R which is equal to V by I, and V value is 8 and I value is 4. So 8 by 4 which is equal to 2. 8 by 4 which is equal to 2. Look at here. Look at here. So whatever the potential difference and current flowing through it, the resistance remains constant. Am I right? Yes. Here the resistance remains constant, that is equal to 2 ohm, 2 ohm, 2 ohm and 2 ohm. Is it clear? But here the potential difference and the current flowing through the conductor is different. So whatever the potential difference and current flowing through the conductor, the resistance values remain same. That is Ohm's law. That is Ohm's law. Because what is it? Here R is constant. What is constant? Resistance is constant. So due to which here the all resistance value is, what is that? 2 ohm, because resistance is constant here. Okay, so this all setup placed in constant temperature. What is that? Constant temperature, because if the temperature increases, the temperature will affect the current flowing through the current. Is it clear? Yes. So the Ohm's law is full is this only for constant temperature. Is it clear? If the temperature increases, Ohm's law is not satisfied. Okay, which means Ohm's law is not okay. Is it clear? Yes. So that's all about the experiment to verify the Ohm's law. Experiment to verify Ohm's law. Is it clear? So look at here. I will repeat again. So this is Ohm's law circuit. The battery positive terminal is connected with one end of the conductor, and this battery negative terminal is connected with positive terminal of the ammeter, and ammeter's negative terminal is connected with the key. Then key another one end is connected with the rheostat one end. So next one, this conductor's another end is connected with the top slot of this rheostat. Is it clear? Yes. Next, here the voltmeter is connected as parallel to the conductor. Here conductor is a unknown resistance, that is nichrome wire. Is it clear? Yes. So this battery which is used to make a potential difference. So due to this potential difference, what will happen? The electrons will move from one part of the conductor to another part of the conductor, but the current will flow from positive terminal to negative terminal, whereas the electrons will move from negative terminal to positive terminal. That is opposite to the direction of current. So already we know very well, isn't it? Yes. So first you set the particular potential difference by this battery. Okay. Look at here. For example, I have set a 10 volt potential difference. How much? 10 volt potential difference. Is it clear? Yes. So already we know rheostat is a device which is used to change the current value without changing the potential difference. Is it clear? Yes. So with the help of this rheostat value, first you set 1 ampere current in ammeter. How much? 1 ampere current in ammeter. If you set 1 ampere current in ammeter, corresponding the potential difference across the 2 terminals of the conductor will be, this is for an example, okay, so will be 2 volt. Will be 2 volt here. Is it clear? Yes. Next one, if you set 2 ampere current, so in ammeter, the corresponding, the voltage value will be, okay, for example, that is 4 volt. Yes. If you set 3 ampere current in ammeter, so by this rheostat, by the adjusting of rheostat, here the potential difference value may be 6 volt. 6 volt, yes. If you set 4 ampere current by adjusting this rheostat, the potential difference value may be 8 volt. How much? 8 volt, yes. So if you find out the resistance for each and every potential difference and current, we can get the constant value of the resistance value. Okay, so look at here, so whatever the potential difference and current, here the resistance value is common, that is 2 ohms for all the measurements. Okay, why? Because here resistance is constant. Okay, already we know according to Ohm's law, resistance is constant, which means R is constant. So whenever, look at here, so whenever the current value increases, correspondingly potential difference value also increases. Am I right? Yes, look at here, for 1 ampere current, the potential difference is 2 volt. For 2 ampere current, the potential difference 4 volt. For 3 ampere, potential difference 6 volt. Therefore, 4 ampere, the potential difference is 8 volt. So when the when the current increases, correspondingly this potential difference value also increased. Okay, so Ohm's law gets verified. Is it clear? Yes. This is Ohm's law proof. You see, after school reopens, definitely we will make this experiment in a laboratory. Okay? Yes. That's all. So with the help of, note this point, so with the help of this data, I am going to plot a graph. I am going to plot the graph for potential difference and current flowing through this conductor. Okay? Yes. So draw this circuit diagram in your class work note neatly. Okay, so draw a graph. This is x-axis and this is y-axis. Okay, yes. Current is taken along x-axis. Current I in ampere. Current I in ampere. So current is taken along a x-axis. Then potential difference taken along a y-axis in volt. In volt, because SI unit of potential difference is volt. Is it clear? Yes. So current value is like a 1, 2, 3. Okay, so the one unit which is equal to 1 ampere. So this is 1, 2, 3, 4. 1 unit which is equal to 1 ampere. Okay. Next, y-axis potential difference. Here this measurement is 2, 4, 6 like that. So here 1 unit which is equal to 2 volt. Yes. So look at here. Next, the graph between potential difference and current flowing through the conductor by Ohm's law. Isn't it? Yes. Here the current value is taken along a x-axis in ampere, whereas the potential difference value is taken along y-axis in volt. Is it clear? Yes. Look at here. Here each and every unit which is equal to 1 ampere in x-axis, and here 1 unit which is equal to 2 volt in y-axis. Isn't it? Yes. For 1 ampere current, what is the potential difference? For 1 ampere current, the potential difference is 2 volt. Yes. So 1 ampere is here and potential difference is 2 here. Yes. So this is center origin, so 0. Yes. Next, for 2 ampere current, what is the potential difference? That is 4 volts. For 2 ampere current is there and potential difference, this is 4. Yes. For 3 ampere current, what is the potential difference? 6 volt. Yes. So 3 ampere is here, then potential difference is 6 volt here. Yes. For 4 ampere current, the potential difference is 8 volt. Yes. So 4 ampere is here, then the potential of 8 is here. Yes. Connect the all points. Look at here. Connect the all points. Yes. Connect the all points. Here the graph between the potential difference and the current will be straight line. Am I right? This is straight line. Can you see clearly? Yes, this is straight line. So why is there a straight line, sir? You may ask me why there is a straight line. Why the graph between potential difference and current is straight line? Why? Because whenever I increase the current value, potential difference also correspondingly increases. Note this point. Whenever I increase this current value, the potential difference value also gets increased. That is the reason why here the graph between the potential difference and current is a straight line. So this straight line shows whenever the current flowing through the conductor is increases, correspondingly potential difference value also increased. That's all. Potential difference value also increase. Is it clear? Yes. So according Ohm's law, the graph between, note this point, the graph between the potential difference and current will be always a straight line. What is that? Always straight line. Why? Because if the current value increases, corresponding voltage also increases. If the current value decreases, corresponding voltage also decreases, due to which the graph between voltage and current will be always straight line. Here the Ohm's law gets proved. That's all. Ohm's law gets proved. That's all, students. Okay. Yes. So after school reopened, we will do this experiment in laboratory. Okay. Yes. So Ohm's law completed. So we have seen Ohm's law theoretical wise as well as experimental wise, isn't it? Experimental wise also we have completed. Yes. So this is a proof. It is a proof. Current is directly proportional to potential difference. That's all, students. Very easy. Okay, yes. So Ohm's law gets verified. Ohm's law gets verified. Is that clear? Yes. So next one. Do you think all things allows the current to pass through them? All the things. Okay, so look at here. I see so many things are here. I see so many things are here. For example, the table is here, the watch is there, then mobile phone is there, then chairs is there, books is there, then fan is there. So many things are there. Okay. Do you think all the materials will allows the current to pass through them? Which means no, that's not possible. That is not possible. Okay. Few materials only allows the current to pass through them. They are called conductors. Already we know. Am I right? Yes. Why they are allows the current to pass through them, sir? Why they are conducts the current to pass through them, sir? Why? Why? Because already I taught in my first video class, because they have lots of free electrons. Am I right? Yes. Because they have lots of free electrons, already we know very well. Yes. There is another one reason. Okay, there is another one reason. Another one reason is that we will see that. Okay, we will see that. Is it clear? Yes. Okay, in free electron wise we have seen in previous video class, but on the basis of resistance, which means electrical resistance, all the things can be categorized into three categories. Okay, all the things can be categorized into three groups. Okay, look at here. On the basis of, note this point, on the basis of electrical resistance. What is that? Electrical resistance. This is very important point. On the basis of electrical resistance, all things can be categorized into three groups. How many groups? Three groups. First one, that is good conductors. That is good conductors. Second one, that is resistors. Third one, that is insulators. Third one, insulators. Okay, note this point, very easy one. See, we see so many things are there. All the things do not conduct the current. Note this point, all the things do not conduct the current. Few things only, okay, in everyday life, few things only conduct the current. Is it clear? Why? Because on basis, note this point, on basis of the electrical resistance, note this point, what is that? Electrical resistance, all the things which are around us can be categorized into three groups. Okay, or we can say three categories. First one, good conductors. Second one, resistors. Third one, insulators. Third one, insulators. On what basis? On the basis of electrical resistance. Electrical resistance. Is it clear? Yes. So what is first one, sir? What is good conductor, sir? Which means, what is it, sir? The title reveals answer. They are good conductors. They are conducts the current. That is good conductors. That is good conductor. Okay, for example, the all metals, the metals such as copper, then nichrome, aluminum, and so many things. Copper, nichrome, aluminum, tin, zinc, cadmium, then gold, so many things are there. Okay, so all metals are good conductor. Note this point, all metals are good conductors. Okay, yes. Next question rising here. So why all metals are good conductors? Okay, if metal conducts the current, why should not the table conduct the current? That is a question. Look at here, if metal conducts the current, why should not the table conduct the current? Why? Actually, what's happening there? That is very big question. Look at here. See, what basis the three groups of things? Electrical resistance. What is that? Electrical resistance. Look at here. Here, the good conductors such as the copper, nichrome, aluminum, and all metals, they have very less amount of resistance. This is very important point. They have a very less resistance. What is that? Very less resistance. Already we know what is resistance. The collision. Note this point. The collision, that is called resistance. Am I right? Yes. So here the good conductors such as the copper, aluminum, tin, and all the metals have very less resistance, due to which they allows the current to pass through them. That is the reason why it is called good conductors. In good conductors, the resistance value will be very less. Okay, yes. So if the resistance is less, already we know the electrons can easily flow from one part of the conductor to another part of the conductor, isn't it? Yes. So this flow of electrons is called current. So we can get the current amount in maximum rate. Is it clear? Yes. Because the all metals have less resistance. Note this point. All metals have less resistance, due to which all good conductors allows the current to pass through them. Which means all the metals allows the current to pass through them. Is it clear, students? Yes. So what is the meaning, sir? What is the meaning for good conductor, sir? Good conductor mean nothing but those substances which have low resistance. Okay, which means extremely low resistance. We can say extremely low resistance or less resistance. Less resistance is called good conductor. So this is only for good conductors. Okay, look at here, I have started only good conductors, not resistors and insulator. Yes. So those substances which have extremely low resistance is called good conductors. Okay, for example, the all metals are good conductor of electricity because they have less amount of resistance when the potential difference is applied across the two ends of the metals. Okay, conductors, generally we say conductors. Is it clear? Yes, already we know what is collision. What is collision? The opposition to flow of electrons. What is that? The opposition to flow of electrons is called opposition to flow of electrons is called resistance. Already we know very well. Here all the metals have less resistance, due to which the electrons can easily flow from one part of the conductor to another part of the conductor. So all good conductors allows the current to pass through them. Am I right or wrong? Yes, obviously that is right. All the good conductors allows the current to pass through them because they have less resistance. Is it clear? Yes, which means less collisions. Okay, yes. So those substances which have extremely less resistance is called good conductors. It's called good conductor. The examples for good conductors are all metals are good conductors. For example, copper, aluminum, tin, cadmium, nichrome, chromium, so whatever it is. Okay, yes. That's all about these good conductors. So what is the concept here? All metals are good conductor of electricity. Am I right? Yes. Why? Because the collision, which means the resistance, is very, very less in good conductors. That is the reason why they allows the current to pass through them easily. For example, the copper, nichrome, aluminum, tin, gold, they all are examples. That's all. So the definition for the good conductor, those substances which have very extremely less resistance is called good conductors. Okay, good conductor of what? Good conductor of electricity, but not any other things. Okay, yes, that's all. Next one, okay sir, good conductors, okay sir. What is resistor, sir? What is resistor? Yes, that is next question. Sorry, here there will not be nichrome. Nichrome will not be there because nichrome is one of the alloy. Okay, so nichrome will not be here. Sorry, nichrome will not be there in conductors. That is also conductor, but it's not a very good conductor. Okay, it will be in the category of resistors. Okay. So next one, resistors. What is that? Next one, resistors. Okay sir, good conductors. Okay sir, what is good conductor? Good conductor, they have very less amount of resistance, due to which electrons will flow from easily from one part of the conductor to another part of the conductor. So we can get maximum amount of current, sir. Yes. Then what is resistor, sir? The title itself reveals the answer. Resistor, something which resists to flow of electrons maximum rate. Okay, maximum rate. Is it clear, students? Yes. So that is next one, resistors. Okay, for example, have you ever used iron box to ironing the dress materials? Yes. Inside the iron box there will be some alloy. Okay, it may be a nichrome, a tungsten, whatever it is. Okay, why should not use any other material, copper, instead of this nichrome? Because nichrome has high resistance. Note this point. Nichrome has high resistance. Nichrome or tungsten has high resistance, due to which it will produce maximum amount of heat. That is the reason why these resistors, which is used in heating appliances, like a toaster, then water heater, iron box, and microwave oven, and so many things. Is it clear? Yes. So next, come to this resistors. What is resistors? That is very big question. So resistors mean nothing but it has maximum amount of resistance. The substances, those substances which have comparatively, okay, not very ultimately, infinitely, comparatively have resistance, that is called resistors. Okay, for example, the nichrome. See, nichrome's not example for the good conductor. Nichrome also conductor, but not very good conductors. You consider this resistor. Okay, yes. So nichrome is one of the resistor. Then the tungsten, manganese, constantan. These all are resistors. Know this point. Resistors, nichrome, tungsten, manganese, then constantan. These all are examples for resistors. So why, sir? Why few things only under the category of resistors, sir? Why? Because they are also conductor. Note this point. They are also conductor, but not very good amount. Okay, not maximum amount. They allows the current to pass through them, but very little amount. Why? Because they have resistance, high resistance compared than good conductors. That is the reason why the resistors allows the current in a minimum amount. They allow the current but minimum amount compared than these good conductors. Is it clear? Yes. Why, sir? Why they are allowing very minimum amount of current, sir? Why? Because the resistors have maximum amount of resistance. That is the reason why it will not allow the current in maximum amount. It will allow the current not in maximum amount compared than this good conductors. Is it clear? Yes. So resistors are the materials, resistors are the substances which have comparatively, okay, so note this point, comparatively maximum resistance. So comparatively maximum resistance, that is called resistors. Okay, for example, those substances which have comparatively, which means moderately, comparatively high resistance, that is called, what is that? That is resistors. So those substances which have comparatively high resistance is called resistors. They have resistance but maximum amount compared than the good conductor. That is the reason why it is called resistors. For example, the nichrome, tungsten, manganese, constantine, they all are one of the resistors. So these resistors plays very important role in heating appliances like a toaster, then electric heater, iron box and microwave oven and so many things. Is it clear? Yes. So what is the meanings are here? So resistors have resistance due to which it is allows the current slightly, okay, which means partially allows the current to pass through them. So those substances which have comparatively high resistance is called, what is that? That is called resistance. What is the word meaning comparatively? Comparatively, which means moderately. Okay, moderate. Now it's not a high amount, it's not a low amount, that is a moderately. Okay, that's all. So that is called resistors. Okay, yes, that's all. Next one, what is the insulator? What is the insulator, sir? Insulator is exactly opposite to good conductors. Exactly opposite to good conductors. Yes, third one, insulator. Okay, look at here. Here, the good conductors allows the current to pass through them. Am I right? The good conductors allows the current to pass through them, whereas these insulators never allow the current to pass through them. Insulators never allows the current to pass through them. For example, it's wood, rubber, mica, okay, and so many things. Mica, the stone, a glass, and so many things. They never allows the current to pass through them. Next question rises here. Why, sir? Why the insulators such as wood, rubber, mica, stone, glass never allows the current to pass through them? Actually, what's happening there, sir? Look at here. These good conductors have a less amount of resistance. Alright, less amount of resistance. These resistors have the high amount of resistance, moderately, okay, which comparatively high amount of resistance. Okay, not a very low resistance, not a very high resistance, moderately high resistance, isn't it? Yes. Whereas this insulator have infinitely high amount of resistance. That is the reason why here the insulator never allows the current to pass through them. They have infinitely high amount of resistance. What is resistance? The collision. So in insulator the collision is infinitely high amount. That is the reason why they never allow the current to pass through them. For example, the wood, rubber, mica, stone, glass, and so many things are there. Most of the things around us are only insulators. Is it clear, students? Yes, that's all. So insulators never allows the current to pass through them. Is it clear? Because the insulators have infinitely infinitely maximum amount of or high amount of resistance. Okay, yes. So those substances which have infinitely high resistance, note this point, infinitely high resistance are called what is that? That is resistance. So in glass, mica, rubber, the resistance value is infinite amount. What is it? Infinite amount. That is the reason why they never allow the current to pass through them. That's all, students. Very easy one. Is there any doubt? No doubt at all. Okay, yes. So again you compare the three things. First one, what is that? On the basis of electrical appliances. What is that? On the basis of electrical resistance, the all things which are around us can be categorized into three groups. First one, good conductors, second one, resistors, and third one, insulators. On what basis? On the basis of electrical resistance. First one, what is good conductor, sir? See, some materials only conducts the current. They are called conductors. Already we know very well. Why, sir? Note this point. Why the conductors only conducts the current, sir? Because the conductors such as copper, aluminium, then zinc, cadmium, so many things, they have very less resistance. Already we know what is resistance. The collision is called resistance. Am I right? When the collision is called resistance, which means the opposition to flow of electrons is called current. In all metals, the opposition to flow of electrons is very less. Now this point, very less, due to which in metals the electrons can flow from one part of the conductor to another part of the conductor easily. So they are called good conductors because they are allowing current to pass through them. Is it clear, students? Yes, very easy one. Here the good conductors have less resistance. Resistance. Isn't it? Yes. Next come to resistors, sir. What is resistor? The title itself reveals the answer, resistor. What is that? Resistors. Yes. Here the resistors also have some resistance. Note this point. The resistors also allows the current to pass through them, but not in the rate of like a good conductors. So here resistors have moderately high amount of resistance, or otherwise we can say comparatively high resistance. Okay, comparatively high resistance. So for example, the nichrome, tungsten, constantine, manganese. So they all are under the category of resistors. They have resistance but not less amount and not high amount, moderate amount. They have moderate amount. So it has moderate resistance. So in resistors, the collision will be moderately high amount. What is that? Moderately high amount. Is it clear? Yes. Here the resistors also allow the current to pass through them, but not as that of good conductors. Okay, yes. Next come to insulators. Third one, what is that, sir? Insulator. See, insulator, look at here. The good conductors have less amount of resistance, yes. Then resistors have moderate amount of resistance, but the insulator have infinite amount of resistance. What is that? Infinite amount of resistance. So the insulator never allows the current to pass through them. So here in the insulator, the resistance will be infinite amount, due to which insulator never allows the current to pass through them, because here the resistance is very high, that is infinite amount. Okay, that's all. So the examples for insulator: wood, rubber, mica, stone, glass. Here the rubber is very important insulator. Even the EB workers also, electrician also use this rubber to protect their body from electric shock. So rubber plays very important role in electric field. Is it clear? Yes, that's all, students. Very easy one. Okay, yes. So good conductors okay, resistors okay, then insulators okay. So everything is okay. So in this session we have finished in this lecture very easily. Am I right? Yes. So in this session we have seen Ohm's law, the verification of Ohm's law, and these three categories of things which is based on electrical resistance and so many things. Is it clear? Yes. So next we will see some numericals. Next we will see what is there, some numericals which is based on Ohm's law. Okay students, yes, so we will see one or two sums. Okay. See, I am going to put particular video, okay, specific video for numericals, only for numericals. Okay, you wait for that. So after school will reopen, we will discuss different kinds of numericals. Okay, yes. So in this session, we will see one numerical which is based on Ohm's law. Okay, yes. Next, I'll put particular video, okay, specific video for only numericals. Okay, yes. So numerical, first one, a simple electric circuit. A simple electric circuit has 24-volt battery. 24-volt battery and a resistor of 60 ohms. Resistance value is how much? 60 ohms. Yes. What will be the current in the circuit? The current in the circuit. Yes, you find out that. Yes, this is question. What is the question, sir? You may ask me. This simple electric circuit has 24-volt battery. How much? 24-volt battery. Yes. And the resistor 60 ohms. Resistor how much? 60 ohms. Yes. What will be the current current in the circuit? So we need to calculate what quantity? The current quantity. Is it clear? Yes. Let's get started. Solution. Okay, according Ohm's law, so V equal to IR. According Ohm's law, V equal to IR. First of all, you write what are the quantities we know. First one, voltage. V values we know, that is 24 volt. That is 24 volt. Is it clear? Yes. Next, R value, look at the R resistance value, how much? 60 ohm. Yes, 60 ohm is here. Am I right? Yes. Next one, what value we need to calculate? Yes, what will be the current in the circuit? So current I value we need to calculate. Is it clear, students? Yes. Look at here. So according Ohm's law, V equal to IR. So I which is equal to what will be there? I equal to V by R. So when this resistance come this side, this multiplication changes into division, so we can get V by R. This is current formula. I equal to V by R. Am I right? Yes. So I which is equal to V value how much, sir? V value 24 volt. Yes. 24 volt divided by R value 60 ohm. Yes. 60 ohm. You further divide both. So 24 divided by 60. What will be the smallest number? So put one dot and add one 0. Am I right? Yes. So 60 into 4 which is equal to 240. Am I right? 6 into 4 24. So it is equal remaining 0. So it is equal to 0.4. So current value will be 0.4 ampere. How much value current? The current value how much? 0.4 ampere. So when, look at here, so when a 24 volt potential difference is applied in the circuit, then the resistance value, then the resistance value is 60 ohm. The current flowing through the circuit is 0.4 ampere. What is that? 0.4 ampere. That's all. This is how you need to make a, what is that? Yes, numericals. Is it clear? Yes. This is one type of numerical, and remaining one type of numerical I will put here. You wait for that. Yes. Another one numerical we will see. So next one numerical, look at here. So second, when a 12 volt battery, note this point, 12 volt battery is connected across an unknown resistor, there is a current 2.5 milliampere, note this point, 2.5 milliampere in the circuit, yes. Calculate the value of resistance. Calculate the value of the resistance. Yes, this is one type of question. Look at here. So when 12 volt battery is connected across the unknown resistor, there is a current 2.5 milliampere, note this point, 2.5 milliampere in the circuit. Calculate the value of resistance. Yes. So solution, according Ohm's law, V equal to IR. First you write what are the values we know. The V value is 12 volt. Here the potential difference is 12 volt. Then the current value I is 2.5 milliampere, sir, here. Milliampere, yes. Then what quantity we need to calculate? Resistance. So R value we need to calculate. So this R value we need to calculate. Am I right? Yes. So potential difference value we know. Current value we know. Yes. Then we substitute this both value in this formula. Yes. Am I right? Yes. Look at here. Before that, before substituting, look at here. Here the current value is given in milliampere. What is that? Milliampere. So we have to change into ampere. Am I right or wrong? We have to change into ampere. Am I right or wrong? Yes, because SI unit of current, what is that? Only that is ampere. But here the value is given in milliampere, so we must change the milliampere into ampere. Am I right? Yes. Note this point. So look at here. I'll write here. 1 milliampere, which is equal to how much? Already I thought. Which is equal to 1 by 1000 ampere. How much? 1 milliampere, which is equal to 1 by 1000 ampere. Milli, which means what is that? 10 to the power of minus 3. Okay, yes. 1 milliampere, which is equal to 1 by 1000 ampere. Then 2.5 milliampere, which is equal to how much, sir? Which is equal to how much, sir? You tell me. Yes. Which is equal to 2.5 divided by 1000 ampere. 1000 ampere. That's all. Very simple mathematical calculation. Yes. See here the both term multiple with 10. We can get whole number. Both term multiple with 10. Yes. So here the answer will be 25 divided by 10,000. Am I right? 10,000, because already 1000 is here, into 10,000. Isn't it? Yes. You further divide the 25 and 10,000. What will be that? 25 and 10,000 is very smallest number. Yes. Put one zero. Sorry. Put a dot. Add one 0, that is also 0. Sorry, that is also smallest number. Again add one 0, here also add one 0. Now also it is very smallest number. Again add one 0, here also add one 0. So now it comes 25,000. Yes, here 10,000. So 2 into 10,000, which is equal to 20,000. Remaining 5,000. Remaining 5,000. Again add one 0. Here 50,000. Here 10,000. So 5 into 10,000, which is equal to 50,000. Remaining 0. So what is the value? 2.5 milliampere, which is equal to, which means current value which is equal to 0.0025 ampere. That's all. 0.0025 ampere. Okay, students. Yes. Now substitute this value, I value, and this voltage value in this formula. We can get obviously the resistance value. Am I right? Yes. So resistance is equal to resistance. What is that? Resistance is equal to V by I. So V by I, already we know this formula very well. Yes, remaining I'll write here. So what is the V value, sir? So V value here 12, R which is equal to V by I. Am I right? Yes, according to Ohm's law, V equal to IR. If you need R value, when this I come this side, this multiplication division, so we can get V by I, isn't it? Yes. So V value how much, sir? So V value 12 volts, sir. V value 12 volt divided by I value how much, sir? That is 0.0025, sir. 0.0025. Okay, look at here. After this dot, how many digits are there? 4 digits are there. Yes. How can we make that, sir? Yes, we can make both term multiple with 10,000. Both term multiple with 10,000. Yes, what will be there, sir? Yes, 12. Then after 12, after 40, 1, 2, 3, 4, 1,20,000. Yes. Then here what will be there, sir? What will be there? 1, 2, 3, 4. 40 and 4 decimal cancel and remaining 25. Remaining 25. It's a simple mathematical calculation. You further divide again 1,20,000 40, yes, and 25 and 25. You first take 3 decimal. First 3 decimal in here. What will be there? 4 into 25. Yes, 100 and remaining 20 here. We bring this 10 here. Bring this 10 here. Is it clear? Yes. Here 8 into 25, which is equal to 200. So remaining 0 and remaining 20 will be there. So the resistance value will be 4,800 ohm. This is one type of question. Okay, the resistance value how much? 4,800 ohm. Okay, yes, so look at here. So whenever the current value is given in milliampere or microamperes, whatever it is, you must change this into into ampere, because SI unit of current is ampere. You must change the milliampere or microamperes, whatever it is, into ampere. That's all. Okay, students, this is how you need to make. Okay, yes, that's all. I hope this class will be very useful for you. Next class we will see next important topics. Okay, students, yes, thank you.